Today's lesson will discuss binomial expansion, and it stems from multiplying polynomials. So here is the long way. This isn't a way that you have to remember or have to know how to do. I'm just going to show you the long way so that you'll be more likely to want to learn how to do the shortcut. So to find a product, x plus y to the third power, here's what this means. This means x plus y times x plus y times x plus y. And we can't do all three of them at the same time, but we can FOIL these two. I'm going to take x times y, and here's what we get. We get x squared plus xy plus xy plus y to the second power. Combine our like terms, we have x squared plus 2xy plus y squared, and we have to multiply that with xy. And so here we go. We get x to the third plus x to the second y. Now I have to do 2xy times x, which would be plus 2x squared y. 2xy times y would be 2xy squared. And then we have y squared times x, which would be plus xy to the second. And lastly, y to the third. Now we'd have to combine like terms. If one of these, if two of them, so my final answer, x cubed plus 3x squared y plus, I can combine those two, 3xy to the second plus y to the third. Look at all that multiplied. Very complicated, a lot of work. I'm going to show you a shortcut to go right from here straight to there with skipping all of that work in between. It stems from Pascal's triangle. Now hopefully you have the sheet that has Pascal's triangle here and these notes. If you look at Pascal's triangle, I want you to pause the video, see if you can come up with the pattern. Now the pattern is, what's 1 plus 1? Well, it's 2. What's 1 plus 2? 3. 2 plus 1? 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And we can keep going. Here comes a 1. 1 and 4 makes 5. 4 and 6 make 10. 6 and 4 make 10. 4 and 1 make 5. And 1. You could keep going and fill out the rest of Pascal's triangle. There's a lot of patterns that come from here. If you want to learn more about that, you can Google it, and there's fascinating features about Pascal's triangle. We're going to use just this piece of Pascal's triangle for our binomial expansion. So if we notice the coefficients of the variables in the final product of x plus y to the third, the problem we just did. These coefficients are the numbers from the third row of Pascal's triangle. Take a look at the third row here. There's our coefficients 1, 3, 3, 1. The numbers out front of the variables. And then we had x to the third plus 3x to the square, 3x squared y plus 3x y squared plus y to the third. We can use this table, this binomial expansion table, so have this with you as we go through a few examples here. So I'm going to show you how this works. We need to find x plus y to the fourth power, and I don't want to do all that multiplying. So we're going to use binomial expansion here, and we're going to use row 4. In which in the end I'm going to have 1, 2, 3, 4, 5 terms. Okay, that might have been confusing. Let's erase that part. So we're going to use this row, this basis. It's a plus b to the fourth. Well, instead of a, I see x. Instead of b, I see a y. So everywhere in here, If I see an x, or an a, I'm going to replace it with x. So here's how this starts. It's going to be x to the fourth plus 4, that's the first coefficient. And then if you notice, it goes a to the fourth, a to the third, a to the second, a to the first, and then there's no more a. Whereas b, there's no b to start, then it's b to the first, b to the second, b to the third, b to the fourth. It goes the opposite direction. So here, if I just have two variables here, I've got x to the third, it's going to drop down 1, and y is going to appear, y to the first. Then my next coefficient is 6. Okay, and I'm going to drop down 1x, so it's x squared. Pick up one more y, so it's y squared. So my next coefficient is 4. And again, I continue the pattern here. X to the first, this would be y to the third. And then my last coefficient is 1. Well, I don't need to write 1. B to the fourth, well, that would be y to the fourth. And there is my final answer. So rather than do all that multiplying, I can use this table to help generate what x plus y to the fourth power is. And that is called binomial expansion. What if we have a number in there? Well, that just requires a little bit more multiplying. It requires one extra step. But we're still going to use the table. And I chose x plus 3 to the fifth power because the fifth power is the highest. It's the most complicated one. So I'm going to walk you through how do we interpret this bottom table here. Well, we're going to view it the same, but in for x, that's like where my a is, and the 3 is where the b is. So to start off, I've got a to the fifth. Well, that's going to be where x to the fifth goes. And I'm going to need to start a little higher. So let's go x to the fifth plus, we have 5, that's the first coefficient. X is going to drop down, so it's going to be x to the fourth times b, which is 3, plus, my next coefficient is 10. We have 10. X is going to go from the fourth power down to the third power, and then that 3 times 3 to the second, plus 10. Right here, it's going to be x to the second now, times 3 to the third, plus we have 5, x to the first, and then 3 to the fourth, and then plus, in the end, we've got 3 to the fifth. So I know I'm kind of running out of room there. Now we just need to simplify. Well, x to the fifth is going to stay as x to the fifth. Now I can do 3 times 5. That would be 15 x to the fourth. Now we can do 3 to the second power. Well, that's just 9. And 9 times 10 is 90. And we have 90 x to the third. Here, 3 to the third power, that's 27. And 27 times 10 is 270. And we've got x to the second power for that term. Now I've got 3 to the fourth. 3 to the fourth is 81. And 81 times 5 is 405. And that term has an x. Plus the final thing, 3 to the fifth power. Well, that would be 243. Now, there aren't too many with x to the fifth power on it, but I wanted you to see one so you may understand what you need to do. If you have x plus 3 to the third power, well, then you would have used the third row. There's not as much multiplying. But whenever there's a number, you're going to need to do some multiplying and some expansion there. If you would like, if you're still confused, ask Mr. Ryan to perform this example for you.